So how's everybody doing out there? Well, welcome to day 15 of Corona Online School. So we've officially hit about the halfway mark of the semester. So good job, everybody. So today we're going to finish up chapter 4, which we talked briefly about in section 4.1, a little bit of least common multiple and greatest common divisor, but we want to formalize it in this section. So let's jump right in. Oh, and by the way, remember we're going to do our review today. So if you want to wait and watch this video afterwards, come to the review during class so that way we can go over any homework questions you might have or any kind of exam review questions or anything like that. So we'll be doing it like about 15 minutes into class starting. So look for the link so you can come and join and ask questions and participate. All right, so let's look at example 1 here. So we want to find the least common multiple of 8 and 12 together. And so this one we're doing kind of the same method we did in section 1, and then I'll show you a new method for later. So what it says is to go ahead and list the first 8 positive multiples of, or first 10 positive multiples of 8. So in this case, we're just going to, take 8 and then 16, then 24, and then just kind of keep going up the list. So 8 times 4 is 32, 40, 48, 54. Oh, hold on, wait a second. What in the world did I just do here? 56. 56, 64, 72, and 80. All right. And now we want to do the same thing for multiples of 12. So we get 12, 24, 36, 48, 60, 72, 84, 96, 108, and 120 in this case. All right. And so again, what we're looking for to find the least common multiple is we want to find, because there could be, if we ran this list out, we're going to see that there's lots and lots and lots of multiples that these guys will have in common. But we're trying to find the smallest one that occurs on both lists. So like if we look, I can see, they both have a 24. They both have a 48. They both have a 72. So even though this list is relatively small, we've got 3 common multiples that they have in common just for what we can see. But in this case, since we're looking for the least common multiple, that means we want to choose the smallest one on both of the lists. So in this case, the smallest common multiple on both lists would be 24. So our least common multiple in this case would be 24. So I always get, these are always tricky and confusing in my mind because you see the word least, and if you look, notice the least common multiple is bigger than both 8 and 12, and so that's what's going to usually happen. So even though it's the least common multiple, it's the smallest number that 8 divides into evenly and 12 divides into evenly. So the least common multiple is always going to be bigger, or could be the same size as one of the numbers, but it's typically always going to be bigger. Where the greatest common divisor is kind of the opposite, and so it'll be a smaller number. So just kind of keep that in mind. And so in this case, I've kind of formally defined what least common multiple is for you. So if A and B are natural numbers, the smallest natural number, m, that's a multiple of both A and B, is called their least common multiple and is just denoted with that LCM notation. So go ahead at this point, pause the video. You do practice 1 exactly the same way I did the one above. So just list out the multiples, find out what the smallest one on the list is, and that'll be your answer. And then when you're done, come on back and then we'll talk about greatest common factor in this case. All right, so did everybody do okay on least common multiple? All right, perfect. So again, let's do greatest common factor. And again, this is similar to what we did in section 1. So in this case, we want to list all the factors of 8. So all the things that divide into 8 evenly. So in this case, 1 should be on every list for factors because 1 divides everything evenly. So 2 goes into 8, 4 goes into 8, And then you always want the number itself, because the number itself always divides itself also. So 1, 2, 4, and 8 are the only factors of 8. And now do the same thing for 12. So we've got 1, 2, 3, 4, 6, and 12. And so again, if we look, now in this case, there won't be an infinite number of multiples, but there could be more than one multiple that's in common. So for us, if we look, notice that we've got 1, 2, and 4 is a common factor for each of these lists. But in this case, since we're looking for the greatest common factor, we want to choose the biggest number that occurs. So when they're using that least and greatest, it's not in reference to how big the number is, it's just compared to all these other numbers. So the greatest common factor is always going to be something smaller than like the 8 and the 12, but it's the greatest of all those ones that occur, because we also had 1 and 2, but those weren't the greatest ones that we can have. So in this case, 4 would be our greatest common factor because it was common to both on the list. And so again, our GCF then would be 4. All right. So again, I've got a nice little definition here for you. So let A and B be whole numbers, not both 0. So for greatest common factor, you could actually have one of them be 0. It'd be a little weird, but it is possible that you can, have one of the numbers 0. And then the greatest number that divides both A and B is called their greatest common factor. So in this case, instead of like the least common multiple had to divide into those other ones, the 4 divides into 8 evenly and the 4 divides into 12 evenly. So that's what we're looking for the greatest common factor. All right. So again, go ahead and pause the video real quick. You guys work on practice 2. So again, it's the same way we did it before. And then when you're done, come on back and then we'll talk about another way that we can actually find least common multiple and greatest common factor that involves using the prime power representation. So come on back when you're done. All right, so hopefully everybody did a good job with greatest common factor. So now what we're going to do is do this in a slightly different way. And so what I'm going to do is I'm going to try to find the least common multiple and the greatest common factor of 8 and 12. And I'm going to follow the rules that we have down here. And then when you guys practice, you'll do the same thing. So in this case, instead of writing them out in multiples or writing them out in factored form, we just want to write them out in their prime power representation. So, and if you forget how to do it, like, and these numbers are small, so you probably could do it, but if it were a bigger number, you could always just do a little factor tree on it. And so like 8 is 2 times 4, and I'm going to circle the 2 because it's prime. And then 4 is 2 times 2, and they're both prime, so I'm going to circle those. So 8 looks like 2 times 2 times 2, but in exponent form, it would just be 2 to the 3 in this case. So that's our prime power representation for 8. And then now do the same thing for 12. So 12 is 2 times 6. 6 is 2 times 3. So again, writing this out, it would be 2 times 2 times 3, or 2 squared times 3 to the 1. So that's our 8 and 12 and our prime power representation. All right, so in this case, we're going to try to find the least common multiple. And so what we want to do is we want to write every prime number that's listed for both 8 and 12. So it doesn't matter if they don't have it in common. We just want to list each and every one of them. So the way I usually do this, I just kind of start off with the prime powers first, and then I'll jump to the exponents later. So in this case, 8 has just a 2. Whoops, got the wrong thing on here. So 8 has a 2. And then 12 has a 2, but since we've already wrote 2, we don't want to write it again. But there's a 3 that wasn't in 8, so we do want to include the 3. And so now what we want to do is go back and choose the highest exponent that occurs for any of these different prime power representations. So in this case, if I look at, let's change to that size. If I look at 2, the biggest exponent that appears on 2 is the 3 that's coming from the 8. And in this case, since there's only 1, 3, then we only have one choice. We're just going to get the one exponent for that guy. So now if we go down here, raise the 2 to the third, raise the 3 to the 1, then what we're actually getting is the least common multiple of 8 and 12 in this case. So 2 to the third is 8 times 3 is 24. So 24 is going to be the smallest number that 8 divides into evenly and 12 divides into evenly. And you can almost look and see, oh yeah, well, that makes sense. That's totally true. And so again, it allowed us to do it without necessarily writing out all the multiples. Now, I'm not saying you can't write out all the multiples. If you like doing it that way, that's totally fine. You can use whatever method you like, whatever way works for you. So I just like to give, if there's possible, multiple ways to do things, so that way you can find which one works best for you. All right. So for the greatest common factor, we want to start off exactly the same way. So the first thing we want to do is write down the primes. But in this case, we're only writing the primes that they have in common. So in this case, since there's only a 3 in the 12, we're not going to include the 3 in our greatest common factor. So we're only going to include the 2 in our greatest common factor. And again, in this case, instead of choosing the biggest exponent, we want to choose the smallest exponent that occurs. So in this case, now we're going to pick up that 2 to the second. And so again, what we've found, once we simplify it, is the greatest common factor. So this is going to be the biggest number that divides into 8 and 12 evenly. So in this case, we get the 4. So the reason we don't include like the other primes is because, again, we're trying to make sure that the number we find divides into 8 and 12. And so if we would have included 3 on our list, then no matter how we multiply these together, they would have never divided the 8. So that's why we can only include the primes that are in both of the numbers, not just in the one number. Where the least common multiple, since we're trying to divide 8 and 12 into this bigger number, we do need to include all the primes in that case. That way we guarantee that 8 divides it and 12 divides it. So it's subtle how these are a little bit different, but that's how they're kind of related together. All right. So again, I don't care which method you use. If you like writing all the multiples and factors out and actually just look at the list, that's totally good with me. If you get good with this exponent form, feel free to use the exponent form. It's up to you however you want to do it. So I've said you do them in prime power, but if you feel like you're not comfortable with that, or you can try both. You can do both methods, whatever you want to do. But go ahead, work on these last couple practice problems. So I got a bunch on here. And so the very last thing is, and this is, isn't majorly important, but it's kind of a cool little thing to notice, is that technically if you've done your greatest common factor and your least common multiple correctly, then if you multiply those two together, so if I multiply my greatest common factor by my least common multiple, it'll actually give me the sum of m times n together. So like if I go back to my last example that I just did here, so in this case, my m was 8, my n was 12, and so if I multiply those together, I get 12 times 8 is 96. And so what happens if I multiply my LCM, which is 24, by my, GCF, which is 4. So I also get 96. So basically what that tells me is that I've got those answers right. So it's kind of a built-in check to make sure that you know that the least common multiple and the greatest common factor you got was correct. So if you got something, more than likely you'd get something bigger. So if you got something bigger, then that means we've messed up somewhere. Like we somehow either miscalculated our greatest common factor or miscalculated our least common multiple. Or by chance we just happen to mismultiply 8 and 12. So I'd check everything just in case. But it does make it nice because it gives you a nice little way to know for certain whether you got the right answer or not by checking that rule. So again, that's it for chapter 4. So we're ready for the exam. So again, hopefully everybody can come to the meet tomorrow so that way we can chat a little bit, go over some homework questions. I'll get to see you guys again. And bring any questions you have and be ready for the exam coming up. All right, so good luck. I'll see you tomorrow.